Good afternoon. If you could turn to this page in your packet, we are going to take some notes about what we call roots of a quadratic function. So what I want you to do is I want you to write the word roots right here. Okay. We are not talking about like simplifying square roots. We're talking about the roots of a function, okay? What does that mean? I think we've used this word before. You probably know it more as zeros or the solution or the x-intercepts, okay? So we're talking about, and specifically with our quadratic functions, the points at which the parabola does what? Intersects the x-axis. So all four of these terms are interchangeable. Whether I say roots, zeros, solutions, x-intercepts, they all mean the same thing. Where does our parabola cross the x-axis? Now, there are three different ways this could look. We could have a parabola, whether it opens up or opens down, cross the x-axis 2 times, and we would have 2 solutions, okay? What would it look like if it only touched the x-axis 1 time? Whether it's opening up or down, this means that our vertex is on the x-axis. It's hitting the x-axis and then turning away. What about no solution? What does that mean? That means we're not crossing the x-axis. So whether our parabola opens up and is above the x-axis, or it opens down and it's below the x-axis, we are not intersecting the x-axis. Okay, so this is why we had you practice some graphing yesterday after your quiz, because what we want to do is we want to graph our function and determine, hey, what are the solutions? Okay, so we are looking for graphically where our parabola crosses the x-axis. Algebraically, that means, hey, when does y equal 0? Okay, so let's talk about graphing this function right here. We know to find the vertex, we need to take negative b over 2a. Okay, and maybe I'll just write this up here, negative b over 2a. Don't forget that we need to use that to find our vertex. Okay, so our vertex is at negative 2. I want you to plug negative 2 in for x. Do you get negative 9? Okay, there's our vertex. Okay, so let's do this. We need to pick a couple points to the left and a couple points to the right. Now, we know that this parabola opens up because our a is positive. So we know we are going to have 2 solutions because this is opening up. We're going to hit the x-axis 2 different times. So how about this? I will plug in negative 3 and negative 4. You work on negative 1 and 0. How about you go ahead and press pause, and then when you have those 2 y values, press play. For negative 3, I got negative 8. For negative 4, I got negative 5. Does that match what you got for negative 1 and 0? Okay, so we know we're going to hit the x-axis, but we still don't know where. So we got to go one more time. Let's see if this helps us. Okay, if we plug in 1 squared plus 4 times 1 minus 5, hey, That gets us 0. That's an important one. Okay. If we plug in negative 5 squared plus 4 times negative 5 minus 5, that's 25 minus 20 minus 5. That gets us 0. Okay. So we're going to make our parabola there. Since we hit the x-axis at x equals negative 5 and x equals 1, then our solutions are negative 5 and 1. Okay. Now, tomorrow, we're going to work on what you guys have already done before. Hey, what if we put 0 in for y, and we can factor this to x plus 5 times x minus 1, because 5 times negative 1 is negative 5, and 5 minus 1 is 4. And so then, yeah, we get the same thing. X is negative 5 and x is 1. Okay, so we will go back to that tomorrow, but today we need to understand what the graphs look like and what it means to be a solution. What does it mean for y to equal 0? That means we have our x-intercepts. Okay, so let's look at number 2. Let's talk about where the vertex is. If we take negative b over 2a, what do we get for our vertex? We should get x is 1. Now, go ahead and plug x equals 1 into the equation. When we get 1 squared minus 2 times 1 plus 1, we get 0. Okay, so let's think about this. This is our vertex. We know our graph is opening up because a is positive. Okay, our vertex is sitting on the x-axis. So here's a time where we know that we're only going to have one solution because our vertex is on the x-axis. So let's do this. Let's at least get our graph. We can't just plot the vertex and call it a day. We need to plug in a couple numbers to the left and a couple numbers to the right of our vertex. So I'm going to have you press pause, and I want you to plug in 0 and negative 1. I will plug in 2 and 3. When I plugged in 2 and 3, I got 1 and 4. Does that match when you plugged in 0 and negative 1? Did you get 1 and 4? Okay, so I need to see the graph, but the important thing is, what is our solution? We hit the x-axis one time at x equals 1. So that is the answer that I want us to write down. Okay, example number 3. Let's find our vertex. Negative b, negative b over 2a is negative 1. Okay, so what's our vertex? Our vertex is at x equals 1. Please remember that when we plug into this equation, we have like a coefficient of negative 1 for x squared. So we're going to plug in negative. The square is only for the x coordinate. So it's almost like we have negative 1 times that number squared plus 2 times 1 minus 3. So what do we get? We would get negative 1 plus 2 minus 3. That gives us negative 2. Interesting. What do we know about this parabola? We know that our a is negative, which means this is going to open down. Is it going to touch the x-axis? We still need to graph it, but we know there's not going to be a solution because our parabola is not going to touch the x-axis. Okay, so let's go ahead and at least finish graphing it. Okay, so we can get the full effect here. Okay. How about you plug in 2 and 3? I'll plug in 0 and -1. Press pause and then press play when you got them. Okay. When I plugged in 0, I got -3. Is that what you got when you plugged in 2? When I plugged in -1, I got -6. Is that what you got when you plugged in 3? If not, go back and fix it. Okay. So when we plot this, here is our parabola opening down, not hitting the x-axis, so we don't have a solution. Now, would you love to know how to determine if we have any solutions without having to graph it? Okay. If you turn to the next page, we have something called the discriminant. And the discriminant is something that we use to determine the number of solutions. The discriminant is something that you'll see again in a formula we use here in a couple days. But for now, I want you to just focus on b squared minus 4ac. Okay, this is called the discriminant, and this tells us, without having to graph it, how many solutions there's going to be. Okay, so if we find the discriminant and it is positive, that means there's going to be 2 solutions. We're going to hit the x-axis 2 times. If we find the discriminant and the discriminant is 0, that means our vertex is on the x-axis and there's only 1 solution. If the discriminant is negative, then we have no solutions. Okay. So remember, A, B, C. If I'm going to take the discriminant here for number 7, we're going to take b squared minus 4ac. If we take 25 minus 16, we get 9. Hey, what do we know about 9? It is a positive number, which means this parabola is going to hit the x-axis 2 times. We're going to have 2 x-intercepts. There are 2 solutions. Okay, let's try number 8. A, B, C. If we take b squared minus 4ac, we have 9 minus 40. That is -31. -31 is less than 0. It's a negative number, which means we are not going to have any solutions. We have a parabola that is not intersecting the x-axis. Okay, look at number 9. We have b squared minus 4ac. Well, if we take 100 minus, look at that, 100, we get 0. And if our discriminant equals 0, then we have 1 solution. The vertex is on the x-axis. Okay, this is what I'm going to have you do. I'm going to have you press pause. I'm going to have you see if you can figure out how many solutions are to 10 and 11 and 12. Press pause and then press play when you have the discriminant and the solutions figured out for all 3. In number 10, you should have gotten a positive discriminant, which means there are 2 solutions. In number 11, you should have gotten 0 for your discriminant, so there is 1 solution. And for number 12, you should have gotten a negative discriminant, which means there are no solutions. Okay? What I want you to